Rapid traffic increase at Dubai International Airport has made quick, safe, and efficient aircraft maintenance absolutely necessary to enable quicker aircraft turnaround. That is why Emirates has set up 8 new aircraft maintenance hangars A to H at Dubai International Airport. This is the biggest aircraft hangars complex in the world, equipped with the most advanced equipment and engineering techniques in the world. ETA, with its reputation for excellence in executing world-class projects under all kinds of environmental and engineering challenges, was chosen to provide vital mechanical, electrical, and plumbing systems in Emirates' state-of-the-art hangars. ETA is led by a vision for a better world through ingenious conveniences and expert workmanship, with extremely high commitment levels. Of the 8 hangars, 4 are capable of handling heavy maintenance procedures and 3 for light maintenance activities, while the 8th hangar, Hangar H, will be dedicated for aircraft painting and cleaning. All 8 hangars have nose docks that enable extensive maintenance procedures on the nose section of various aircrafts. Of these, only 4 heavy maintenance hangars have fuselage docks that enable maintenance access to the wings and fuselage areas of aircrafts. In supplying world-class technical support systems to the 8 new Emirates hangars at Dubai International Airport, ETA has once again proven itself as an engineering superpower in specialized applications. An example is ETA's specialized retractable housing for power cables in the fuselage docks. This enables safe and smooth extension of retraction of the cables during fuselage dock operation. All the hangars are provided with support facilities and are connected to plant rooms that have chillers, cooling towers, electrical supply sources, and other equipment vital to aircraft maintenance procedures. Technical pits. Advancement in aircraft maintenance technology has resulted in underfloor technical support systems that enable a vehicle-free hangar floor. The result is easier and safer maintenance operations. ETA has installed these new generation capabilities at the Emirates hangars in each of the 12 technical pits located in every hangar. These technical pits provide supplies needed for maintenance activities and are housed underground, flushed with the hangar floor. When locked away, they can withstand a rollover of 90 tons. When required, the technical pit can be unlocked from the ground and lifted to operational level with minimum manual effort. They can be stowed back with equal ease. There are 5 different types of technical pits used here, and each complies with National Fire Protection Association (NFPA) standards and all international standards requirements. Let's take a closer look at each type. The 400 Hz power pit gives power to the aircraft in the standard international power format for aircraft, which is 400 Hz. It sources its power from the ground power unit and uses intrinsically safe socket systems that conduct power only when they are plugged in. This pit has 200 amp sockets for use in various maintenance operations. It also has water and compressed air outlets. There are 7 electrical pits in each hangar that provide 3 different sockets of 16 amps, 32 amps, and 65 amps, apart from having water and compressed air outlets. These pits cater to maintenance procedures that require the versatility that they offer. Preconditioned air system. The preconditioned air system used by Emirates is unique in the world. It originates in a fixed centralized unit located just above the nose dock in the hangar, as opposed to the conventional preconditioned air systems that are mobile. An insulated duct carries the preconditioned air from the centralized unit through underfloor pipes to the preconditioned air pit. From there, the preconditioned air is pumped into the aircraft cabin where it maintains a temperature of 23 to 24 degrees centigrade. That ensures comfortable working conditions for technicians inside the aircraft. Fuel exhaust system pit. An important safety precaution before maintenance work commences on an aircraft is to remove even the smallest trace of fuel vapors from the fuel tanks. Even though the aircraft's fuel tanks are mechanically emptied before bringing the aircraft into the hangar, the fuel exhaust system are used to suck out even the last traces of fuel vapors from the aircraft. ETA's fuel exhaust systems in the Emirates hangars do this effectively. The fuel tanks of the aircraft are first connected to a high-efficiency suction fan through pipes. The suction fans are then turned on. They draw out every trace of fuel and vapors and flush them out efficiently and safely into the ambient air, away from the hangar. This procedure greatly reduces the risk of fire during maintenance operations. Fire suppression system. Deluge system. The fire suppression system in the Emirates hangars employs the highly dependable deluge system that gets activated automatically in case of fire. It provides a double line of defense against fire. A fire pump in the building N pumps plain water, while a foam pump located closer to the hangar pumps a mixture of 97% water and 3% foam. This foolproof fire detection system is made up of 2 parts. The first part is the linear heat detection system. It is a highly sensitive matrix of wires placed in the ceiling that detects the exact coordinates of any fire and sets off the fire alarm. The fire's coordinates are relayed to the central fire control room. This activates the second part of the deluge system, which is called the triple IR system. This system is made up of 3 infrared cameras that shoot pictures of the site of the fire reported by the coordinates given by the linear heat detection system. All this happens in milliseconds. Within 3 seconds of the linear heat detection system detecting the fire, the 2 oscillating monitor cannons under the high fire risk area under the wing of an aircraft start jetting water, swinging both ways in a wide arc. These water cannons can also be controlled manually if necessary. Within 10 seconds of fire detection, the overhead sprinklers start sprinkling a mixture of foam and water from the ceiling in a 30-meter radius of the coordinates of the fire. The deluge system takes away 2 out of the 3 components required for fire. It reduces temperature and separates oxygen from the fire. So even if the third element, which is fuel, is present, it is rendered harmless by the deluge system. Mixed index ducting. Mixed index ducting is a special system used for air conditioning within the Emirates hangars. ETA has used this economical air conduction system because it is easy to erect and operate. It evenly disperses cool air to all parts of the large hangars. This homogenized air system costs much less to operate and, being light, does not tax the roofing with extra load. The building management systems. The building management systems employed at the Emirates hangars control and manage various equipments and systems in the hangars. A central control regulates the HVAC to balance temperatures and humidity levels in the hangar. The building management systems control lighting levels based on lux requirements or on a time basis. They also control the hangar doors and compute exact closure to maintenance airflow and air temperature at optimal levels, while taking external wind factor into consideration. These systems guide the radio control cranes inside the hangars. The graphical station for the visual monitoring of the building management system is located in the building N, where all the central controls are located. Information technology for communications. For the Emirates Hangars project, ETA has set in place an advanced communication system. It uses wireless internet telephony to establish contact between various sections of the hangar. The public address system. The public address system that ETA has installed in the Emirate hangars consists of a combination of column-mounted and ceiling-mounted speakers with enough sound throw to reach one end of the hangar from the other. This capability is especially useful to help overcome the high noise levels in the hangars, since the orders coming over the speakers are critical for the maintenance technicians working in the hangars. In the prestigious Emirates Hangars project, those were some of the features that ETA was involved in erecting, testing, and installing. To sum it up, the successful commissioning of the Emirate hangars is yet another great achievement for ETA. It is a significant contribution towards the remarkable progress of the UAE. Most importantly, it is yet another challenge that ETA has successfully overcome through enterprise, dedication, and excellent coordination.